Okay, in 9.7, to do your homework, you really want to pay extra attention to the extra homework help because that will help you a lot with this assignment. But we're going to solve applied problems involving exponential function. We're going to solve applied problems involving logarithmic functions. The very first problem says that we've got an electronic cigarette and it was launched in 2007. Since then, the sales have increased from about 20 million in 2008 to 500 million in 2012. And they have given us an exponential function that represents this. X is the number of years after 2008, and it models the sales in millions of dollars. So we're going to use this information about the estimate and to estimate the sales of e-cigarettes in 2001 and 2015, and we're going to round to the nearest million. So in 2001, X represents the number of years since 2007, so e-cigarettes weren't even here in 2001 according to this information, so we can't really do that one. But in 2015, we could say that from 2007 to 2015, there are several years that have gone by, so 8 years. And that's what we're going to want to plug into our function to figure out what our estimate for e-cigarettes would be after 8 years. So I'm just using our function that we have right here. So if I plug in 8 for x, 20.913 times 2.236 raised to the 8th power. X is the number of years since 2008. And so 8 years have passed. And so you're going to use your calculator, and we're going to type that in. Okay, and I'm coming up with 13,067.4. Now they want us to round this to the nearest million, so we would say 13,067 million. Now, we talked a little bit in class about how this is not really, a good estimate of probably what happened, just because that's so large of a number. And also there was a lot of negative media attention that happened with e-cig, so you can't always just go on the numbers. You also have to kind of look at the other outlying data. So, but in this problem, according to this model, that is correct. Example 2 says, this is an advertising. A company begins an internet advertising company to market a new phone. The percentage of the target market that buys a product is generally a function of the length of the advertising campaign. The estimated percentage is given by the exponential function. F of t is equal to 100 times 1 minus e raised to the negative 0.04t, where t is the number of days of the campaign. So they want us to find F of 25, which basically means that we are targeting certain people. And if you've done any post on Facebook or any searches, or you've been on social media, you know when you're being targeted because things are coming up that you've been looking for, maybe searching for. And so you'll have an ad for something that you're like, that's strange, that's something I was looking for, because they've got some kind of algorithm that is targeting you. And this is what this is saying. So it costs money to advertise. So what they want to do is find the minimum amount of days where they can get the maximum amount of customers to buy their product. So they're trying to figure out, well, what percent of our target audience would be buying our product if we advertise for 25 days. So based on this model, if we plug this in, okay, I'm just plugging in 25 for t here. We're going to get 100 times 1 minus e to the negative 0.04 times 25. Okay, and it comes out to be about 63.21, and it keeps going from there. So if we advertise for 25 days, about 63.2% of our target audience is going to buy our product, which is pretty good based on this model. So they would want to see, well, how much does it increase over time? You might want to look at what 30 days would do, because eventually you don't want to keep advertising if you're going to get a very small percentage buying your product, because it would cost more to advertise. Okay, example 3 says, in a town whose population is 3,500, a disease creates an epidemic, and the number of people infected T days after the disease has begun is given by this function. Okay, and so it says how many are initially infected with the disease. So the first time they're just saying, well, let T equal 0. So we would be doing 3,500. On the bottom, 1 plus 19.9 times E to the negative 0.6 times 0. Okay, and so you could easily plug this into y equals in your graphing calculator and use the table to find a lot of these answers. This might be the smartest thing to do here. Okay, this one's going to be 167.46. And it kind of depends if they want you to round up or down. You can't have 0.46 of a person. So after 0 days, this is about where we're at. So the next question says, what's going to happen at 2 days? What's going to happen at 8 days and 16 days? So we're going to change that 0 from 0 to 2, then to 8, and then to 16. So at 2 days, and depending again if they want you to round up or down, I'm getting about 500.45. If I plug in an 8, 3,007.46, and if we plug in a 16, um, 3,495.29, depending on what we're supposed to round to. So actually, this question is asking us, are we ever going to be able to get this model to be 3,500? And so, all right, basically, are we ever going to be able to get the answer to be 3,500? So we've got 3,500 is equal to 3,500 times 1 plus 19.9 e to the negative 0.6 t. So when you're working through this problem, what's going to end up happening is it's going to force you to take the natural log of 0. So I'm going to go ahead and work this problem out for you to kind of show you where you're going to get this, but the answer is this is actually going to be an asymptote, and so no, it's not going to work. So to work this problem out, I'm going to get this 19.9 e to the negative 0.6 t. I'm going to move it to the top of the fraction. So what I'm going to do is multiply by that on both sides of my equal sign. Because that's going to force that to cancel out on this side. And these are going to be gone. So I'm just really have 3,500 is equal to 1 plus 19.9 e to the negative 0.6 t times 3,500. Well, when we divide both sides now by 3,500, because we're just trying to get that t to move down to the front, so we're trying to isolate that. It's going to be 1 on this side. On this side, I'm going to have 1 plus 19.9 e to the negative 0.6 t. I'm going to subtract 1. It's going to be 0 is equal to 19.9 e to the negative 0.6t divide by 19.9 on both sides of my equal sign. Going to get 0. The 19.9s will cancel out e to the negative 0.6t is what we're going to be left with. And then we're going to want to take the natural log of that on both sides. The problem is this is not possible. You can't take the natural log of 0 because that would be e to the what power is going to give you 0. Well, there's not one. So the answer is just going to be no. It's not possible to make that be equal to 3,500. So that is the end of 9.7. I would strongly encourage you to look at the homework help because it really does help you a lot more with the homework. I'll go through the problems individually on that.